This is part 14 of the series Right Triangles and Trigonometry. In this part, I'm going to work another example using law of cosines and law of sines. In this example, we have an obtuse triangle, it appears, that has three sides and no angles. Because it has no angles, we can't start with the law of sines. But this problem does present an interesting issue that, if you're not careful, can cause major problems. And that issue is we have two smaller angles, as evidenced by their smaller side lengths, and one larger angle. In situations where you have no choice but to use the law of cosines, you always want to solve for the largest angle first. And it's the recurring issue that we've looked at twice before in this series, and that is that using the law of sines, when you're dealing with angles, you're going to be using the arcsine function. And arcsine only generates angles between negative 90 and 90. In this case, they're all positive angles. So the largest angle you can create using law of sines is going to be a 90-degree angle. So it's important to use the law of cosines to find your biggest angles. And that way you're ensured that your other angles have to be obtuse, because this is in fact a triangle. So that's what we're going to do. And in this instance, this is the more complicated instance of law of cosines. So this work is going to take us a little bit longer. So let's dig in and see what this problem has in store for us. Because we're looking for C first, angle C, we're going to start with this side. And the law of cosines says C squared equals A squared plus B squared minus 2AB cosine C. Now let's fill in our pieces. C squared is this guy, so this is 30 squared equals A squared, and that's this side because it's opposite angle A, 23 squared plus B squared, which is going to be this side, 13 squared minus 2AB cosine C. And it has to stay C because we don't know that angle. That's what we're going to be solving for. Now we've got to isolate this angle C. So we're going to start that long process here, and we're going to move to the top of the page over here when we get done. So 30 squared minus this, we're going to subtract 23 squared from both sides, minus 13 squared, subtract 13 squared from both sides, equals negative 2 times 23 times 13 cosine C. You'll notice that I'm rewriting these. I'm not doing the calculations yet because I don't want to have to deal with large numbers. I want to use my calculator for what it's designed for, and that's calculating. So I'm going to divide both sides by this whole quantity here. So what we have is 30 squared minus 23 squared minus 13 squared over negative 2 times 23 times 13 equals cosine of C. And now finally, let's go ahead, move this all up over here, and we're going to take the arc cosine of both sides of this expression. So we have arc cos of 30 squared minus 23 squared minus 13 squared all over negative 2 times 23 times 13 equals C. So what I did is I took the arc cosine of both sides. Arc cosine canceled out cosine and gave me C on the right, and the arc cosine of this side is this over here. Now this is what I'm going to put in my calculator. So let's go ahead and pull up our calculator. So we're going to have arc cosine. So arc cosine. We want to put our entire numerator in a parenthesis. So that's 30 squared minus 23 squared minus 13 squared. And then I can lump those all together, divided by, open another parenthesis series, negative 2 times 23 times 13. I could have used parentheses, but no sense in making extra keystrokes. And close the whole thing off, and that should be my angle C. And as you can see, it's an obtuse angle, so that would have caused us problems. So 109.7. Now I'm going to store this before I leave here. So store alpha C. I'm going to store this in angle C. 109.74. So this is approximately 109.74. 109.74 degrees. Now that we have this angle, we should be able to use the law of sines to find these two angles, because they're both going to be acute angles, because you can only have one obtuse angle in a triangle. So let's set up one for angle A. So we know that sine A over A, 23, equals sine C over C. As I've stated before, it's rarely a good practice to use computed values that are approximations in new computed values. But with the law of sines and law of cosines, we don't really have a lot of choice. So we try to mitigate the problems by storing as many decimal places as we can in our calculator and try to reduce the amount of induced error that propagates throughout the problem. So again, here we're going to go ahead and solve for A. So we're multiplying both sides by 23. So sine A equals 23 sine C. And you know that this C value was stored. So I'll just go ahead and put a circle around it just to tell us that that is a value that we stored in our calculator. And that's divided by 30. Now we take the arc sine of both sides because we've got to unlock this angle. So A equals arc sine of 23 sine C, looks like the copyright symbol, over 30. Okay, let's put that in our calculator. We have arc sine of, open a parenthesis level, 23 sine alpha C, because we stored that value, divided by 30. And that gives us 46.18. And that is A. So we're going to store that into A. Don't know if we'll need it, but we'll store it anyway. So this is 46.2 approximately. All right, so that gives us angle A. (46.2 degrees). And now, actually we do need it. It's a good thing we stored it, because we're going to subtract these two values from 180 to get B. So again, we go back to our calculator, and we have A and C stored. So it's just a simple matter of doing 180 minus what we stored in A minus what we stored in C. And it gives us 24.1 approximately, 24.1 degrees for B. and that solves the triangle. So just as a recap, what we did was the first thing we had to do is solve for the biggest angle first, because we wanted to get the obtuse angle, if there is one, out of the way, and the biggest angle is always going to be biggest the opposite side, and so that's what we use the law of cosines for. Law of cosines works well with large angles. Law of sines, you can use it when you know the large angle, but arc sine only generates angles between -90 and 90, so that would be a problem. So it's always, what you need to do is use law of cosines for your biggest angles, law of sines for your acute angles. Well, I hope that helped. I hope this series was helpful, and I will talk to you in the next series.